This video presents the elastic component NETTO, developed by POLITO. This component provides detailed monitoring of the Linux kernel's network stack and is suitable for real-time operation thanks to its highly efficient eBPF-powered instrumentation engine. In a typical Linux server, the network stack is responsible for processing network packets, on which it implements several functions such as forwarding, filtering, drop, and more. NETTO uses the eBPF technology to instrument all these functions directly in the kernel, thus minimizing latency and operational overhead. Within the elastic architecture, NETTO holds a spot in the monitoring and detection section. Here, our tool will implicitly interact with most other components in the Demonstrator 1 environment, collecting important diagnostic information related to the CPU utilization of their operating system's network stack. The multiple data sources will then be incorporated into a single, cohesive dashboard for easy consumption of the analyzed data. To understand NETTO's internal architecture, let's first consider an example of a typical processor timeline from the point of view of the network stack functions. When NETTO is loaded on the system, it installs an eBPF component that implements a sampling profiler for the kernel. NETTO will interrupt every available CPU at a constant and configurable rate. 1 kHz is used as a balanced default. When an interruption takes place, the processor's stack trace is sampled and lifted to the user space side of the tool. Here, analysis of the traces coming from the kernel is performed outside of the network stack's critical path, thus causing minimal slowdowns to the operating system. Finally, high-level metrics are extracted from the traces and exported to a pyroscope daemon connected to a Grafana dashboard for consumption. Now, I will briefly demonstrate the deployment and use of NETTO. Together with the source code, NETTO's repository provides everything that's necessary for deploying the tool in a cloud-native way. This includes a Docker file for building NETTO's container image and a sample Docker Compose script that automatically deploys NETTO together with all of its dependencies, namely Pyroscope and Grafana. After cloning NETTO's repositories, starting up an instance is as simple as running Docker Compose up. This will automatically build NETTO and deploy it within the container runtime. The Grafana service is exposed on port 3000 and can be accessed via HTTP. There, a sample dashboard is provisioned within the Grafana deployment to demonstrate NETTO's output. The dashboard is presented as a dynamic flame graph view of the metrics exported by the NETTO probe in the kernel. To demonstrate the effectiveness of NETTO's results, let's load the machine with a synthetic networking workload by deploying 2 iPerf3 instances over a bridged pair of network namespaces. After starting the transfer and waiting a few seconds for the dashboard to converge, NETTO correctly shows that most of the total CPU time is being spent receiving and transmitting network data. NETTO's main design and implementation is complete, and its code has been published as an open-source project. The future work for this component is the continued tracking of the Linux network stack's functionalities to keep the tool functional between kernel versions. Additionally, deployment of the tool to the Demonstrator 1 environment is yet to be finalized.